Look at prisms and cylinders today. No, it should be in that other one. Right in the back. The next one down. So, what was a prism yesterday? How did we name the prism? By the base, right? So, a prism is something that has has two bases that are parallel. Let's put congruent up here. Two congruent bases that are parallel to each other and any kind of polygon. And again, this is how you name it, right? This is how you name it, whatever that polygon is. Okay? So if we have a triangle, then we have a triangular prism, right? Now, the difficulty a lot of the times is trying to draw these things. So the key to this is to draw a triangle here, and then draw a triangle, hopefully, that kind of resembles, because they should be the exact same, right there. And then you connect the vertices. Okay? So that's not too bad. This one right here, why would I put this as a dash line? Because it's on the other side. You can't really see it, right? Okay? So this is my triangular prism, right? Because it has triangles on it. So remember, the bases are those polygons, but what did we call the other sides of this yesterday? Not the bases, but the what? Faces, right? The faces are always what shape? What? Rectangles. Let's say parallelograms. They're probably going to be rectangles, but if we say parallelograms, then we definitely hit everything that it should be. So, when you say a triangular prism, it's pretty easy to see what the bases are, right? Because the shapes that aren't rectangles in that case, or a parallelogram, are obviously the bases of that prism. When you get a rectangular prism, a box, that's where it gets a little difficult to determine what the base is. Okay? So you look at this and you have to determine what the base is to you. Is it what it's sitting on? Maybe. And then it would be the top and the bottom. Maybe it's the two sides. Maybe it's the front and the back. Okay? So when we get into what we're going to do today, it's going to be a little different with a rectangular prism compared to a prism like this. All right? Meaning if the shape is something besides a rectangle. All right? The bases then always have to be congruent, as we had already up there. And then we talk about an altitude. What's another word for an altitude? It's just a height, right? So my altitude in this case is what? What would you say is the altitude in this shape? Okay, so how else would you describe that besides the long edge or the top part? This would be the distance between the what? There you go. Between the bases. And because we are always talking about a height, what should it form? What should the height form with the edge? It should be the highest point, so realistically this should be a 90-degree angle. Okay. Now I might not say, so what I'm talking about here is when I can draw that little box right there, right? I know that this has to form a height. Okay? So when we talk about a height and that it's a perfect 90-degree angle, this means that we have a regular prism. In my opinion, you kind of want a regular prism. You want it to be perfectly straight up and down. Or they will call this, instead of regular, this is what we would have called it when we were dealing with the polygons, right? A regular polygon. Now they're going to say it's a right prism. That means it stands up straight, like this, or like this. So it's perfect, okay? Any idea what it's called if it's a prism, but it's kind of slanted? Good guess. So this is one kind. My other one is an oblique prism. And to me, an oblique prism, an example of this is, have you ever seen a picture of the Leaning Tower of Pisa? How the building just kind of bent over? That's kind of what an oblique prism is. I'm not going to lie to you, I can't really draw them. So, hopefully, we got a picture of this. Thought I had this all set up, and then it really didn't work, and it was frustrating me. Come on. Section. What section are we on? 12.2. Anyway, sorry. So this would be, I can kind of do this a little better with a cylinder, even though it's not a true prism. It'd be something like this. So it's just kind of on a slant. All right. Now, obviously, this isn't a true prism. This would be a cylinder, but we're going to get into cylinders in a little bit. But anytime that you hear the word oblique, it just means that it's on its side, or it's kind of leaning over. So, if I was trying to find the height in something oblique, where would my height have to be? It's going to be on the outside. And so you're going to make like a dash line right here, and you're going to make a height on the outside. So instead of the distance between the two bases, it's still my distance between the two bases, but I have to get a straight 90-degree perpendicular segments, so I got to make it on the outside. That makes sense? Oblique ones get a little bit more confusing, but we'll get there when we get there. Okay? So again, that's kind of what we talked about yesterday. Throw in a couple more things. Now we start talking about what this section's about, and we're going to talk about the lateral area. What's the lateral area mean to you? Any idea? So if I have my shape, again, if I go back to my right prism, okay? The lateral area, to me, is the guts, or the middle portion. So when you think about lateral area, I'm going to honestly take the area of all the what? The faces or the sides. Exactly right. All the faces or sides. And like I said, to me this is like the guts or the middle of it. So if I asked you, first off, and this is where it gets a little sticky, again, if I have a rectangular prism, because if I ask Jazz, what is the base? She's going to say what? The bottom. Okay? Anybody look at this and not see the bottom and the top as the bases? Somebody else see it different? Fair enough. So, everybody then, do you see the sides on this that I'm not touching? Those would be considered the lateral or the faces of it, right? The top and the bottom, Jazz said, are the bases. So even though they're still rectangles in this example, she considered them the bases. So this one right here and this one down here are bases, so they don't count as lateral faces. The ones that you see as I rotate it like this are all the lateral faces. So one way that I could do this, if I'm going to try to find the lateral area, is try to find the area of each one of those and then just add them up. Sometimes that gets a little hard, especially if it's a 20-gon, right? If I have a 20-sided figure as my base, I would have 20 different rectangles and try to find the area of each one of those rectangles. I wouldn't want to do that, right? So there's got to be a way of making it simpler, right? And that's where we tried to make a formula. So, LA. Again, make sure when you write these down that you put the correct capital or lowercase letter. This is really, 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 really important. Okay? So LA is going to equal. Everybody understand what LA means? No. The lateral area. Okay? Capital P, what do you think that means? Perimeter. But it's the perimeter of what? What am I taking the perimeter of? Okay, but what specific side do I have to take the perimeter of? The what?
The bases.
The bases. So the perimeter of the base. Now again, this is only for right prisms. Right prisms means that it's exactly straight up and down. Okay? Because would you all agree that when Jazz said that it's the top and the bottom, that this top and that bottom are the exact same rectangle? So when I take the perimeter of the top, I take the perimeter of the bottom. Agreed? Okay? So we're going to take P times H. What's H mean? Height. And how do I know what the height is? This is again where it is the distance between the bases. So this is again really important that you understand what your base is. So did you see why I asked everybody what the bases were? Let's just say Merrick said, well, I think the bases are these two sides. So he's going to do his perimeter, but his perimeter going to be the same as Jazz's perimeter? No, because obviously that little rectangle is way different than that rectangle. Agreed? But when Jazz then does her height's way shorter than when Merrick does his height between his two bases. So it all works out. But if you're going to compare answers when you're doing your homework and stuff, and Merrick picks one of the bases and Jazz picks another, and Kenzie could actually pick another group, she could have done the front and the back, their perimeters are all going to be different. Their heights are all going to be different, but their answers should all be the same. That makes sense? That's really important in this concept. Yeah? So, lateral area. If I don't have a right prism, meaning they don't go up and down, straight up and down. Okay? It's slanted, it's oblique. That means I have to find the area of every single part of the inside. Okay, so this is for right prisms. If I'm going to find the lateral area of oblique prisms, I'm simply going to find the area of each face and add together. Now, I could do that every single time if I wanted to, but it does end up being a little bit longer. Okay. And again, it's only the faces. So you got to still figure out what your bases are. And then just figure doing the area of every single part. Okay with that? So then from there, we go on to the surface area. Of a right prism. So what's the difference between the lateral area and the surface area? The complete outside, right? So when we talk about the surface area, I always think about it as describing it as you wrapping a gift. Okay, you would want to know how much paper you needed to have. Okay, so the surface area is the two bases plus all the faces. Well, this is good because we just found what? All the faces, which we call the lateral area, right? So when you do the surface area, we are going to take the lateral area because we need all the faces anyway. So you can either write lateral area in here, or again, what did we use to find the lateral area? Capital P times H. So you can write it either way. And then we're going to, as it shows up here, plus, we're going to take the, what else? Now, remember when I told you about the capital letters and the lowercase letters? This is the huge one right here. So we're going to take, how many bases are there? 2. So I got to take 2. And then I'm going to put the capital B here. So even though that I'm talking about a base, I'm talking about the area of the base. Not little base, which was the base times the height. That makes sense? So when I put capital B, this is the area of the base. So why do we have to say it this way? Well, because now, what could my base be? It could be a parallelogram. Or a rectangle, a square, whatever, right? What else could it be? It could be a triangle. It could be a regular polygon. It could maybe be a trapezoid, but I doubt it, but let's put it up there. So why am I putting all these up here? Is because you have to then be able to remember all of those formulas for the area of each of those shapes. So that's basically what we did last chapter, right? So what's the area of my parallelogram? Base times height, little b times h, right? What's my triangle? Regular polygon. 1/2 PA, capital P, little a. Trapezoid. 1/2 height, base 1 plus base 2. Exactly right. So I'd have to find each one of those and then figure it out. Okay? Make sense? So, obviously then, if I wanted to do any prism, this is again a right prism. If I wanted to do any prism, meaning that my bases weren't perfect, then I would just have to find the area of every single polygon that was given to me in the shape. We probably wouldn't have too many of those. But you would just do all of the sides and both of the bases. Okay? Questions here? So, the next part of this then is going from right prisms to cylinders. But realistically, a cylinder is a prism. It's just what? What's the difference? It's always going to have a what? Yeah. So, we now look at a cylinder. And the only difference really between a cylinder and a prism is that in a cylinder, the bases are always circles, so they don't have any straight lines in them. All right? But essentially, it's pretty much the exact same thing. So, when we talk about a cylinder, we introduce a couple more vocabulary words. The first one is the axis of a cylinder. This is simply a segment through the middle of the center. Of the two bases. And then the other one is the height. Well, we already talked about the height. What is the height or altitude of a prism? It was a segment that was what? Between the two bases, but it had to be what kind of shape or what kind of property. So this is a segment between the bases that is perpendicular. So here's the question. Is there anything different between these two things? The axis of a cylinder and the height of the cylinder? What do you think? There's not? Why did you say no? You just like no today?
50-50.
Okay. So why did you 50 towards no? You're right. Why would I say that these are different but also the same?
Axis doesn't have to be perpendicular.
An axis, exactly right, doesn't have to be perpendicular. So when are these the same thing?
Because it goes from the same exact length once we go to the same exact length.
So when are these the same?
When it's a regular cylinder.
When it's a regular or right cylinder, exactly right, awesome. So if it's a regular cylinder, it's straight up and down. I'm gonna have this, like Bo just said, from one point to the other, and it's straight up and down. When it's a right or regular cylinder, the axis and the height or altitude are exactly the same thing. They're right down the middle. But in my, what was the other kind? Oblique. So now I have my oblique cylinder. See how it's slanted? I still have an axis because Bo said it had to go from the same point to the same point. So it goes from the center to the center. But my height has to be where? It has to be 90 degrees. So it's that. So my height here is that dash line. My axis here is that line in between. When we talk on this, they're the exact same thing. That makes sense to everybody? So the axis has to connect the center to the center. If it's straight up and down, then they're the same thing. If it's slanted or oblique, the axis still connects the center, but it's different to the height. The height or altitude always has to form a 90-degree angle or be perpendicular. Make sense? So, let's talk about lateral area and surface area. Let's see if you can figure this out before we even write it. So if we do the lateral area of a right cylinder. So again, it's a right cylinder just because it's straight up and down. What was the lateral area formula in a prism? Okay, capital P times H. But what do we know for the perimeter of a circle? The circumference. So, the lateral area is, what's the perimeter or circumference then of a circle?
Pi times diameter.
Pi times diameter. or 2 pi r. So I'm going to have that perimeter still, and then I have to have my h. So this is my lateral area. Everybody agree with that? Perimeter times the height, or the altitude. And then what's my other one? So then we could have the surface area of a right cylinder. So surface area equals. I can write it just like I did over here, the lateral area plus 2b, right? I can still do that. But because the lateral area kind of changes, we can rewrite the surface area as whichever one of these you like better. So 2 pi RH or pi DH. So whichever you're going to choose for your perimeter, plus 2 times b, but what is the area of a circle? Pi r squared. And why is there 2 of them? Because there's one on the top and one on the bottom, right? So 2 pi r squared. So that's my formula. So basically, the only thing that you really have to concentrate on is putting the right things into the correct spot into a formula, and then being able to stick the formula into your calculator. Again, now when you do this, I would try to not round until the very, very end. You're just going to be more precise and more precise if you don't round. Now again, if this is an oblique one, you just have to make sure that you go through the process of figuring out your answer, and you might have to actually do what here? What kind of triangle did I form? This would have been a right triangle, right? And this axis, when it's oblique, would actually act as my what of my triangle? A hypotenuse, because it's opposite of my 90-degree angle. So that brings back what? Trigonometry. That brings back special right triangles. All of that good stuff, Jazz. Don't shake your head. We like all that stuff. Okay? So let's look at a couple of examples. Back it on in there, big boy. You got me kind of dizzy right there. So here's my first one. Find the lateral area of a regular hexagonal prism. So again, you got to go back and think, what's my formula for a regular hexagonal prism? Come on. You got 8 more minutes. What's the lateral area of a prism? pH, right? So the perimeter of what? What's my base in this? Regular hexagon. A hexagon is what? 6 sides, right? Some of you said pentagon, some of you said pentagon's not even up there and you're guessing pentagon. Come on, people. So if it's a regular hexagon, what's my base? Is it the rectangle or is it the hexagon? It's the hexagon, right? So what's the perimeter of my hexagon? Why? 5 times 6, right? There's 6 sides of a hexagon and one side is 5, so 6 times 5 is 30. What do I do with that 30? Take it times 12, right? P times H. Was my lateral area was P times H, right? So my perimeter was 30. What's my height? The height is the distance between my hexagons. So what's 30 times 12? What's 3 times 12? 36 and put a 0 on it. 360, right? What is my label? Centimeters squared. We're still doing area. Okay, so it's got to be centimeters squared. Holy cow, you guys almost killed me right there. So there's my answer. What did you say there? Huh? Here we go. Regular octagon. What is my perimeter? 24. That's better. Voted, just throw out a pentagon for no reason. So what do I do to 24? Times 9. So what's my answer? Whatever 24 times 9 is. I know that's way too much effort for you to write down. Jeepers, you guys. I don't know. Alright, so here's the question. Here's the question right here. Just think to yourself, what is the base of this? That's the key to this problem right here. Kenzie, what's your base?
2 squares.
So you're going to do the front and the back. Anybody different? What do you see, Bono? Which one? Okay, which rectangle? That it's sitting on, maybe? The one on the bottom? And the one on the top? So when he does his lateral area, is it going to be the same as Kenzie's? The answer is going to be the same, but her perimeter and his perimeter are going to be different, right? What's the perimeter for Kenzie? What's your perimeter? If you did the front and the back. 24. She's going to do 6 plus 6 plus 6 plus 6. What's Bondo's if you did the bottom? 12 plus 12 plus 6 plus 6. So she got 24, he got 36, but we're going to get the same answer. Because what's her height or distance between the two? She's going to take her 24 times 12. Bondo's going to take his 36 times what? 6. See the difference? But it's still going to be the same. And then at the end, they would just take their areas of their bases. Okay? So that's where you just got to stop a little bit and see what is the area of the base. Okay? Same with this one right here, right? Is there any argument what the area of the base, or sorry, what the base of this prism is in this one? No. It has to be the what shape? The triangles. If it's a prism and it's not a rectangle, those have to be the bases. That makes sense? Okay? So then we can find the lateral area and we can find the the base, area of the base. Okay? This one right here, you might have to do a little work to figuring out one of these sides. So notice here, when I draw this altitude, what would this altitude do to 12? It would cut it in half. So I would have 6 here, 8 here. I might have to find this hypotenuse by using Pythagorean theorem. A squared plus b squared equals c squared. Okay? Yeah, that sounds great. Okay. So, the only difference here, now I have circles. So notice my lateral area again. They use 2 pi RH just because they had an R instead of a D. And then to find the surface area, they just added their 2 pi R squared. So to me, a cylinder is way easier or simpler because it's always the same. I don't really have to think about it, not even in a rectangular prism, right? A rectangular prism could have multiple answers along the way. A circle is always going to be the same if I compare it with somebody else, because everybody's got to do the same. The 2 circles are always going to be the same in the sides. That makes sense? Okay? So a lot of this is putting things into formulas. If you don't like putting things in formulas, you're going to struggle in this section. If you do like that, it's going to be a piece of cake, as long as you can remember the formulas. Okay? Don't forget to round at the end, wait till the end, and make sure that you go through the order of operations. Okay? So like right here, we want to square it first and then multiply. Don't take 2 times pi times 14 and then square it. You got to go by the order of operations. That's really important for this. Okay? Questions? I know, a lot of stuff for a Friday. So there's the ones you have to do. You can do all of them if you want.